Next we have, now let's learn how to plot the graph of cos x function. Again, I use the same strategy. I write down a table of values with some x values and then find y values from the function. X is in radians again. At x is equal to 0, cos of 0 is 1. So the point on my grid would be 0, 1. So at 0, the graph is at 1. At pi by 3 is 60 degree, cos value is half. So at pi by 3 somewhere it will be half. Pi by 2, at pi by 2 cos is 0. So pi by 2 comma 0. The point on the graph will be here. 2 pi by 3. At 2 pi by 3, the cos's function's value is negative half. So my point is 2 pi by 3, comma, negative half. So somewhere here, the value is negative half. At pi, the cos value, cos of pi is negative 1. So we have pi negative 1. That would be here. 4 pi by 3, it's negative half. So somewhere here. 3 pi by 2, the cos function value is 0. 5 pi by 3, cos function value is half. At 2 pi, it is 1. So my graph of the cos function looks somewhere here and then here. So if I can draw a curve through that, a smooth curve, it goes down. It looks a little like sine wave, but it is a different, its period. Again, I took the values from 0 to 2 pi, right? So we have the x value is lying between 0 to 2 pi. And this is periodic function, so we can just extend it. So the curve is going down. The highest it goes is until 1. The lowest it goes is until negative 1. So the range of the cos function would be from negative 1 to 1. And the x value, cos is defined for all x values. So the domain of the cos function would be negative infinity to infinity. The domain of the cos function would be negative infinity to infinity. The range of the cos function, again, it does not take values less than negative 1. It does not take values higher than 1. Cosine function is an even function. That means it is symmetric with respect to y-axis. Symmetric functions are, what does even function means? The function is called even function if f of negative x is equal to f of x. And we learn that cos of negative x is equal to cos of x. So cos is an even function, so it is symmetric with respect to y-axis. Cos function is also periodic, means it repeats itself after every 2 pi. X-intercept, where does the graph meet x-axis? At all the points where at pi by 2 the graph was 0, so that is x-intercept. At 3 pi by 2 the graph was 0. At 5 pi by 2 the graph is 0, and so on. That means odd multiples of pi by 2. Then we have negative pi by 2, negative 3 pi by 2, and so on. All these are x-intercept. Graph is meeting y-axis only at one point, right? Where is the y-intercept? Where x is 0, the y value is 1. So y-intercept is at point 0, 1, where x is equal to 0. The maximum value is 1. Where does this occur? Maximum value occurs at 0 and at 2 pi, at 4 pi, and so on. Where does the minimum value occur? The minimum value of the cos function is negative 1. It occurs at all pi's multiples, odd multiples, negative pi, pi, 3 pi, 5 pi, and so on. All odd multiples of pi. The function value is negative 1. Now we learned what is cos function basically look like. How we can use that to plot different cosine functions. They look, now this cos function has the basic function same as cos of x, but it is transformed. How is it transformed? X is changed from x to 2x. That means it will be compressed horizontally by a factor of half. And what does negative 3 mean? That means that the graph will Negative 3 means y is changing from y to minus 3. So the graph will move down. The original cost function graph will translate down, or you can say move down by a factor of 3, by 3 units. The graph will move down by 3 units. Okay. So let's see. What does that mean? So whatever was happening at 0 will be happening at 0. So that is here at 1. But now it goes down 3 units. 1, 2, 3. So that is the highest point of the graph. Whatever was happening at pi by 2, at pi by 2 the graph cost function was 0. Now that will happen at pi by 4. Now at 0 point will be going 3 points down. So here at pi by 2 the graph was 0, but whatever happens at pi will happen at pi by 2, which is negative 1. So now it is gonna go negative 3 here. So our new graph would look something like this. So the original cost function is compressed by a factor of half, and it is moved down by 3 units. Okay, it's gone down by 3 units. So we can plot all the graphs using transformations if we know the basic graph. Let's try it on our calculator. Clear what we have before. Cos of 2x minus 3. So it should be compressed and it should be moved down by 3 units. So the highest point is negative 2. So on the calculator also, the highest point is negative 2. So the domain is still same, negative infinity to infinity, but the range of this graph will be from negative 4 to negative 2. So what is sinusoidal functions means? Sinusoidal functions are, they are very important functions. They are defined in dictionaries as of relating to or shaped like or varying according to the sine curve. They look like sine curve basically. This means that any curve that is the transformation of the sine curve is called sinusoidal function. Let's graph one more time cos function. I know we already did. At 0, this was 1. At pi by 2, it was 0. At pi, it was negative 1. 3 pi by 2, 0. And 2 pi, right? So this is your cos function. Let's plot the sine function on the same grid. Okay, this blue one is cos function. I am trying to plot sine function. At 0, this is 0. At pi by 2, 1. Pi, 0. 3 pi by 2, 2 pi. So if you notice, what is the difference between cos function, the blue one, and the sine function, which is the purple one? The sine function is the cos function moved to the right by pi by 2 units, right? So the shift of the graph, this curve, is to right pi by 2 units. So it's just moved right by pi by 2 units. So cos of x minus pi by 2 is the same as sine of x. So cos function is also just the transformation of sine function. That means cos function is also called sinusoidal function. Cos function is also just a kind of sinusoidal function.